And we are live. Should be live. Are we live? Yes, we are. And so back to the machine we started last night. Done a bit of the boring stuff out of the way. As you can see here. Let's move this keyboard. There we go. That's better, isn't it? So we are removing, or we have removed the ANTIC socket, the CPU socket, and the POKEY socket. And I've also put a socket where the MMU used to be, right about here. These sockets, the original machine sockets, they did not take much persuasion. I just clipped the cross members and rocked them backwards and forwards, and they slid right out. So I'm just removing the solder from the holes that are left, and then we give it a little clean up, fit some nice new sockets, and then we'll take the RF mod off the board. Also, beforehand, since I'm aware that the cables that arrived with the ultimate 1 megabyte aren't going to be long enough, I'm just going to close that door a bit. Could I do with the light on? Need more light. Yes, so since I'm aware that the cables that came with the ultimate 1 megabyte aren't going to be long enough to travel right across the board, I've manufactured some new ones. So now we have a OSROM cable which is going to plug in here, travel across here. Similarly, the MMU cable is going to travel across the board something like this. You see? Something like this. So everything's going to fit. So that's some of the hard work out of the way. But what I haven't done yet is the I was going to crimp a load of bits of wire. I haven't done that yet, because that's boring. Now, I'm still using this pump to get the solder out of the holes that are left here. Now what I found useful, since I've got a new soldering iron, I usually use this come on, focus. Not going to focus. Try that. There we go. I usually use this beveled tip, which needs a bit of a clean. But it occurred to me that this this pointed tip would be ideal for getting rid of the solder from these holes here, and it is. So we'll just line up the pump on the back side of the board, a little bit of heat, and there we go. And it does make for a very clean job, much cleaner than using the flat side of the beveled tip. So I learned something. Because with the other iron I was using, I never ever used to change the tip. That bevel tip went on, it stayed on for about 5 years. I still find it the most versatile shape, but got a pack of tips here, might as well use them. Get the feeling there's still a bit of a socket leg in that hole. So we'll add a little bit more solder. This is leaded solder. Conducts heat better. Got flux on the board as well. But yeah, these old sockets came out really nicely. That doesn't want to come out, does it? Usually this is the signal that I'm about to burn a trace off the board, but let's try it from the other side. Ooh. Oh, it did not want to shift. It was well and truly clogged up. The board again. I'll have a look at this. I'll come back to you. There's always one. Every other hole is cleared without any problems. Someone on last night's video commented with a link to an electric desoldering pump, which looks pretty good. But I don't honestly, when it comes to just unblocking, removing solder from the holes like this, I don't really mind using this thing. But I can see for removing chips, a proper powered desoldering pump would probably be a good thing. Going well. Going well. No problems until we hit this problem. This stubborn pin. Right, so one left. What we're going to do about this? Add some flux. Which one is it? That one. I'm going to turn the iron down a bit. Because I'm worried about this thing falling apart. Let's try again. There we go. Got you. Flux, the power of flux. Okay. Let's give you a look at this. Flip the board. Right, where are we? Come on. Focus. Come on. There you go, so it needs a little bit of a clean up, but you can see how clean those holes are with this pointy tip. Works really well. That didn't take long. So let's give this a little bit of a clean and put some nice sockets in. Big fan of flux. I like a lot of flux. Didn't used to be. I used to have these awful ropey, dry joints, but I would not be without it. So we'll clean this up, give it a visual inspection, because I'd rather see any problems now than after the socket's in. And we can also see if there are any holes that need a little bit more cleaning up. Any holes that have anything stuck in them. Right, looks good. Right, let's have a close inspection. Just holding the window is normally enough. That looks pretty good. Looks very nice. Have a look after cleaning. Isn't that nice? Doesn't that look nice? Where's Pokey? I think pin 37 on Pokey still has a bit of solder in it. Let's just whack the socket in and see what happens. Am I short of a socket? No, I've got enough. Lethargic actually sent me enough sockets to do the whole job. That's great. Right. Double check the back of the board. I do not want to be hunting down shorts and things later on when things don't work as expected. What are you? I mean, I'll continuity test anything that looks suspect at this point, but it looks good. I think everything's fine. If there's any trace repair to be done, now is the time to do it, not when the socket is on the board. Yeah, that looks good to me. My trademark blue tack. Hold the socket flush with the board. A little bit of flux. I'll do the corners first. I'm going to stick with this tip. I might stick with this tip for a while. Kind of like it. Okay. Does that look flat on the board? I have to do the corners, 2 or 4 corners, and then push the socket down. Make sure it's as flat as it can be, and then we can go ahead and do the rest of the pins. Oh, I like this tip now. With it being pointed, it seems to concentrate the heat very nicely. Made a fairly interesting discovery today when I was dismantling an 810 disk drive for cleaning. I did not realise that the 810 disk drive's case, the 2 halves of the case, upper and lower, are completely identical. It's a good money saving technique by Atari. So they only had to have 1 mould for both halves of the case. So the apertures at the back for the I/O ports, the drive select switch, etc., are just covered up with a label on the top half of the board, which is why the drive has a name badge on the back. I did not know that until today. Interesting factoid. Right, more trademark blue tack. should probably have done this one bit at a time, and the sensible thing to do would have been to socket one chip and check that everything still worked, and then what to hell with it. We just replace everything and hope for the best. That's the way I usually do things, and it usually works. Very satisfying putting these precision sockets on the board. No, I do like this tip. I really, really do like this tip. Which one did I just do? Right, it's the two middle ones. Ooh, we need more solder at the front of ANTIC socket there. A little bit miserly. Nothing could be worse than the original sockets. When I pulled those sockets apart, seriously, there were some legs that just didn't have any solder around them at all. Okay, and finally, pokey. Also took apart a 1029 printer today, which I've got to re-ink. I've got to peroxide it and re-ink it. I've never seen one of those up close either. Very modular. The whole mechanism, the whole chassis of the print mechanism just lifts straight out of the case. I'll put more flux on there because there's some junctions of traces where they're just probably dying to become a short. Almost there. Looks good. All right. I would have liked to have watched the socket removal. Yeah. Yeah. I'll make a point of doing that next time. I will make a point of recording the socket removal next time. I just it's a bit of a brutal process. So and I'd never done that live on camera before, so I didn't. If I'd realised it was going to go as well as it did, I would have recorded it. But I'll bear that in mind for next time. Okay, so what we can watch is removing this thing. This is going to be fun, because I have not yet removed the RF modulator with a temperature controlled iron. Now the annoying thing that they've done here is they've twisted the lug and then soldered it on, so we're going to have to twist and heat and twist. Where are my other pliers? Where are my other pliers? Pliers! Where are you, pliers? Pliers! There we are. There are my pliers. Nice ESD protection. Which ESD protection are you talking about? Right. Actually, I start at the back. There we go. Twisted it straight. Now, is this going to be the right tip for the job? We'll see. So what I do here may not be the best way of doing it, but that's the way I do it. Is I heat this up and wedge a screwdriver underneath the back. and just by increments the thing basically comes off without flexing the board too much. That is the plan. It's always worked before. Heat the sides. It's because the back's further up, it's naturally they're gonna work their way out. I couldn't really give a shit about these locating holes and things. I just want this thing off. Need a bit of persuasion at the side. I realise you can't see what's going on here, but I've got a screwdriver wedged under this big hunk of metal, just levering it up gently as possible. There we go. The other side. The back out yet? Nearly. Just about. There we go, it's nearly off. I've always found it easier to remove solder first. Did you use wick or desoldering pump or? You have more patience than I do. There you go, it's off. I'm gonna have to get one of these electric desoldering pumps. If if they could make short work of this job, then it's something I definitely need to have. Remove these wires, clean up these holes, make them look a little bit more presentable. Now I'll use the pump now. And this is the wrong tip now. I'll change tips. I'll have a little bit of a clean up. So we're going to clean these holes up, but looks pretty clean. Now what's going to go here, I shall show you what's going to go there. Aside from the ultimate 1 megabyte, which is going to go around about here somewhere. I'm just going to try and figure out what, probably, yeah, drill a couple of holes about there, around about there. It'll be quite low on the board as well, which is good. Oh, hang on, that's too far along. Got to avoid that cartridge pylon. So where are we going to put things? Put this back for a minute. Right, where can we put this? Is anything just ahead of there? No. Right. Well, we know we're going to put this now. We're going to put this right about there, because these cables are going to go around this way, so they're not going to hit anything. That's going to work out beautifully. So that's what's going to go there, and behind that, around about, yep, around about here, a DIN13 connector for our RGB video. And I'll have to run off a template for the DIN13 pins, the tiny little DIN13 pins. Is the audio still loud enough, by the way, because I've moved the microphone away from my mouth to try and avoid these plosive sounds and breathing sounds and stuff like that. Right, let's change this tip. Ah! Right, which tip will we go for? We're going to go back to the bevel tip. We'll try this narrower bevel tip. Right, just wait for that to heat up. Sounds good? Okay, thank you. Good. Sound has been a headache. Right, what else can we do while I'm waiting for this iron to heat up? Aha. Oh, yes. Supplies. More stuff that I bought. Here we have pylons. Now these are 15mm M3 nylon standoffs for the ultimate 1 megabyte. Where have I put that? And they go under here like so. This kind of idea. Keeps it nice and low on the board. I mean, there's nothing under here. Now, the other thing I'm going to have to worry about is clearance on the VBXE. Where's the VBXE? Let's have a look, see. Oh, and another socket. Another 40-pin socket. I'm actually a 40-pin socket up. Ah, it's broken. Never mind. I'm going to test fit this VBXE to see if any of the components behind the ANTIC socket are going to get in the way. If I can get this socket off. There we go. Eventually I'm going to do another 1200 XL, one of mine, and it's going to have VBXE etc. in it, and I will film socket removal on that machine. Right, is this going to hit anything? Possibly not. God, that's tight. It doesn't hit anything. Quite surprising. Blimey. That's tight. And I think what I'll do with this, can you see this? These pins here, it's very difficult to see, but I'll wick some of the solder off those pins. There's a lot of spare solder on these pins here. I mean, it makes for a nice secure fit, but that might be okay. That might be I wonder if this was put on deliberately. I'm wondering if these pins have been caked in solder deliberately so that it's a very, very tight fit in the socket. Which is fair enough. So we don't even have to move anything here. So let's go ahead and clean up this the side of the RF modulator if we can. Might have to get some wick on it. And then we can move on to the next stage, which will be drilling the holes for the video socket. This pump's rubbish. I've got to buy an electric one. This doesn't have to be a work of art, it's just politeness. It's common decency to remove the solder. It's a charitable act. And also it makes the machine lighter, saving wear and tear on the owner's arms when he's using the machine. Oh, I chopped that off, didn't I? Forgot about that. I don't remember if there's a piece of metal in there or not. Is there? No. Alright. Nothing in there. Nothing in there except soda. So we'll persevere with trying to remove it. Finally. I'll wick the rest of that off. Where's the wick? Where's the wick? This is rapidly reaching the point where I really don't care. This is good enough. Right, clean it. A clean cotton bud. Right. There we are. Now I'm going to have to go away and find the template on the other machine. Where is my template? Where is my template? Is it in Dropbox? Documents? Photos? No. DIN3, there we are. DIN13 resized, that's the fella. I think I print that out from the bitmap editor. Print. Let's try that. Let's see if this is the right one. Come on, print. Come on, print. Communication. Oh. Is the printer turned on? Is the cable properly connected? Oh, what have I done wrong here? What's wrong with the printer? Is the printer even plugged in? Ah, no. Are you? Ah. What's this? What the hell is this? Ah, what on earth? Yes, that's right. Printer's plugged in here. That's it. I forgot this printer's network now on this router, and I have to run this silly little program that lets me print do it on the network. Right. What the hell? Well, that's a bit too big, isn't it? This is a little bit too big. I think this is a little bit too big, this printout. So let's try that. Right, what did I do wrong? File, print. I know what I've done wrong. That's no good. How did I do this? Fit picture to frame. Try this. Let's try that. Ah, this looks a bit more like it. Yes. Finally. Hello, 1, 2, 3, send. There we go. That's actually the correct size. So we're going to cut this out and we're going to tape it to the board. So this little template shows us the footprint of the DIN13 connector. So that we can drill the holes and let the pins go right through the board. You know, and I used to do these on my machines because, after all, it's only me. I used to just dig a hole that was big enough for all the pins to poke through the board so I could wire it from underneath. Actually, the first one I did, I think I glued it on sideways or upside down like this and wired it up, but yeah, eventually I would sort of dig a horrible hole here So all the pins would just poke through, and then Candle said, why didn't you use a template and cut the holes properly? So some of my machines look really nasty because they've got the one big hole for all the pins, but everybody else's gets this. Right, now the trick to aligning this thing is to make sure that we don't hit anything on the other side. The last thing we want to do is hit some traces on the back side of the board. So there's nothing on the back, so you want yeah, there's only one other thing we need to take into consideration here. Can you guess what it is? That's right, the hole that's already in the back of the case. We're going to have to work around this so we can adapt the hole that's already there. So for that reason, our jack wants to be about there, so that when we enlarge the hole, we don't have we don't want to end up with two holes. Nobody wants two holes, we just want one. But I don't want it to be too far along. Ideally that to be dead center. But if we put it dead center, and I'll mark that off with a pen, the optimal position would be about, this is one situation where it's actually useful to have a camera because I can see what I'm doing. Right, the optimal position is about there, but what if we put it there, what are we going to hit on the other side? Oh, and we're going to hit a whole load of traces if we put it over there. It's possibly unavoidable. What are we going to hit? So if we put the connector here, we are going to hit, ooh, right, so we're going to have to go further along, closest we can get, and I'm aware this isn't the side I'm going to put the template on, but about the closest we dare go is about there, which is, right. So we're going to line this up exactly with the right hand edge of the silk screen for the RF modulator. So the correct position, like so. Make sure it's straight. And that looks to be about spot on. Press this down to make sure it's stuck on. Check again that it's straight, which it appears to be. Is it straight? Straight enough. So here's our template. That is where we are going to drill holes. We're going to get the Dremel. I really don't want to do this on camera. I really don't want to do this on camera though. That's not the drill size. This one's broken. I'm going to get my other drills. Where are they? Not there. Oh, shit. Not there. Only one place that could be, isn't it? Aha. And we're back. Right, this appears to be the drill in question, so let's get cracking. Oh, I need a piece of wood. Right. I don't want to drill through the desk, if possible. Right. Now, find a chuck. Smallest chuck available. This drill is about, what is it? Is it a millimeter? I think it's 1 millimeter. Too big. Aha, there we go. That's the one I'm after. Right. Oh, get the key as well. Ah, got the chuck. Right. Bear in mind we will have to grind off the copper once we've drilled the holes, but don't grind off the copper before you drill the holes, because I guarantee if you do it that way you will never ever be able to drill the holes straight. Because the centre punch works best on the metal. Right. Okay. Hammer. I think I'm going to mute this because I don't know what it's going to do to. I don't know what this banging is going to do to the sound. Hello. Lost audio for a minute. And we're back. So we've drilled the smaller holes. I'm going to drill a couple of slightly bigger holes for the do I need larger holes for that? No, perhaps not. Alright, nah, forget the larger holes. Let's just stick with what we've got. Yeah. Right. We'll need the Dremel again when we come to do the hole in the back of the case, but for now we are finished. For the moment of truth, let's have a look at what we've got. Oh, very nice. So there we have the array of holes for the DIN13 connector and the two little shield pins at the front. Look at that on the back of the board. Where are we? There you go. So what I used there when the audio was off, I went and I got a cork placemat, because since the Atari motherboard isn't sitting flat on the desk, I needed something to sort of wedge in here. So we should have a connector which pushes perfectly into those holes. That would do if the pin wasn't bent. Let's try again. Snug is not the word. Alright, try again. There we go. Have a look at that. Come on, focus. There we go. Look at that. So we can solder the wires for the RGB signal to those pins. And for all the world you'd think that was a factory connector. Of course we have to, well, that's tight. Hello, Atari fan. What are you doing? I am working on a Atari 800 XL. I'm just going to have a whole load of upgrades in it. And right now we are drilling the board for this DIN13 RGB monitor connector. I've just used a template to drill these holes here, and into those holes the connector fits perfectly, although annoyingly I have got it about 1 or 2 degrees off square, but never mind. Now the next thing we need to do is grind off this copper. interesting solution. Yes, I went into a little bit of detail a few minutes ago, probably before you started watching. I used to just drill a big hole here, just a big old hole, big enough for all the pins to fit through. And then it was Candle who suggested that there was a bit of a neater way of doing it with a template. I didn't know such a template existed, and he sent me the template, and I lost the template and had to make my own template, which is what I used today. But it does work very well, and it looks factory. It does look more or less factory. So I'm gonna get that little placemat again. Right. Now we're just going to grind off this copper. Your microphone is only in the left channel. Ah, that's interesting. I must be doing something wrong here with the mixer. Let's have a look. Tell me if it's any different if I down mix to mono. I've just clicked down mix to mono in Open Broadcaster. If you could tell me if that's any different, I would be very grateful. Meanwhile, I'll look for a little brush. Ah, so that worked. Thank you. Thank you. I learned something. So we can see we've just missed. Now, which trace is it? Is it the composite video trace? We've just missed the composite video trace, but that was intentional. That means it's gone right. A little bit of cleaning up. We'll just clean the board off. I might as well hot glue the connector in place before we wind up. Right. Oh, it's got dark. It's gotten dark. That was George Benson style. This Dremel, I've had the thing for years and it's actually pretty good. Draper El Cheapo Dremel, but it's not bad. I like to try and tidy up as I go. So I'm going to put this away. Left this the key. Right, so that is all the dremeling we'll do until we cut the hole in the keys, because we're going to cut a hole. Put the board in the keys. Where are we? Right, so if I drop that connector where it's got to go, if I can get it in there. I should have done that before I put the board in, shouldn't I? There we go. So that's our new, where are we, RGB connector. So as you can see, I'm going to have to enlarge that hole, which was for the RF modulator, so that it's big enough, so that it's the same size as the rest. But it's quite tricky because this RF modulator hole always ends up in the bottom corner of the bigger hole. So, but once that's done, you'll see that we have a jack which is mounted on the board and lifts right out. Any advances in GUI theme? These boards are tight in these cases. Yeah, the last time I worked on that, I think it was earlier, it was either early this year or late last year, and I was trying to get to the point of having driver modules, but I hit all kinds of stumbling blocks. The thing uses the MADS assembler, and it uses the proprietary relocatable file format of the MADS assembler. And these relocatable files, they only allow one segment per file. Now if you think about that, if you have a, let's say, a driver for the side cartridge, an SIO level driver for the side cartridge, if you have all of the driver code in banked memory, and your applications in banked memory, and your file system drivers in banked memory, when the application requests some I/O, and the device driver tries to burst some data into the buffer, which might either be a DOS buffer or an application buffer, if the code doing the I/O transfer, well, it can't really be in the same address space as the data or the application or the file system handler. So what in the case of SPARTA-DOS-X, the relocatable file format allows for, I think it's three different segment types all in the same file. You've got a fixed, an absolute segment, and you've got which is at a fixed address, that's non-relocatable. You've got a main segment and you've got an extended segment, and the main and the extended segments are both relocatable. So the main extended segment relocates down to memlow, and the extended segment relocates to wherever the extended bank pointer is, and all the addresses for all three segment types get fixed up so that code from any segment can call code from any other segment. But although it does have to take care of banking in the DOS bank at the appropriate point, but it all works nicely. The side driver that I wrote for well, the side soft driver for SPARTA-DOS-X uses that exact structure. It's got an initialization segment at hex 3000, I think it is, and then it's got a main segment and an extended segment, and all of the sector transfer code is in the main segment, so that you can, so that even if the sector transfer is going to an extended bank where the DOS, because SPARTA-DOS can keep the sector buffers in extended memory, the code that's doing the transfers is never in the same address space. Now these MADS proprietary relocatable files don't have any provision for this kind of thing, so it's a little bit more difficult. And but I was getting on quite well with it, but just other things got in the way. Doing a lot of hardware stuff, and of course the ultimate BIOS and all that kind of thing. And it's certainly not a lack of enthusiasm. There may be a level of procrastination involved subconsciously, because there's a tendency to overcomplicate things. I actually emailed Produtron, the author of Symbos, about some of the driver architecture issues I was running into to do with the mouse. I was kind of tempted to make the mouse, for example, a device handler along the lines of Unix, where an application would open the mouse like a file, a stream, if you like. But Produtron said it was far too overcomplex, and the simplest possible option is the best possible option. He's probably absolutely correct. So I think about it a lot, and I will come back to it, but there's only so much I can do. Now I know it's something that people are interested in. They enjoy watching its progress. And I had a couple of people saying, would I consider open sourcing the thing in an effort to get it to move along a little quicker. But that's not really something I feel like doing. And if it gets to the point where I know that it's not going to progress, I mean, I'll know when I'm not going to finish it, if it gets to that point. Because right now it just seems to me like something that I'll work on as and when. And I would say it's about half finished. And I'm probably at the point where it's a difficult point designing file system drivers and the whole driver architecture. It's a difficult stage. It's a bit like designing the window manager. It's of that kind of magnitude, really. So it was bound to be one of those stages where it was either going to progress at breakneck speed, or it was just going to prove not so much a stumbling block, but just what's the word I'm looking for? Just like a natural break, I think, is. Because if you look at something like Symboss, which is the best 8-bit graphical operating system there is, as far as I'm concerned. It took a long time and it was done in fits and starts, but yeah, I mean, I'm pleased with what was being achieved so far, but still a lot of work to do. But it's definitely, it's not something I've just forgotten about, and it's not something I'm trying to just brush under the carpet as if it didn't exist. Certainly not. But I haven't written much code at all lately. But yeah, I hope to get back to it. It's kind of clearing the decks. The ultimate BIOS is finished. The incognito BIOS is finished. All that hard disk stuff that I wrote's pretty much finished. So there's not a lot else to do. So when I do get back to coding, that's what I'll be working on. Put it that way. Negro 04. Negro 04. Hey bro. Why did I read that out? Yeah, I was just going to do the same thing. I caught off guard a little bit because I haven't usually got many people in Twitch chat. I need to get modded. But thank you. Bye bye. Ah, 2 viewers in Twitch. One was a troll. Who knew? This is a seminal moment in my streaming. The first time I've had to ban someone from a chat. Okay, so we've cleaned the board up, and will we glue it in? Shall we glue it in? Yeah, let's glue it in. We might as well glue the connector in before we finish off. Now this is a job. I sound like I'm having a seizure or something because I'm bending over under the table to plug stuff in, and I'm getting old. So we've got the glue gun plugged in, so what we're going to do with this is, and what I'm a little bit worried about actually, is how I'm going to get this thing to, how am I going to get this thing is this even going in the correct hole? I thought I was going into the wrong hole. Definitely don't want that. Because I don't want to start hitting problems when the glue's already on the board. This is one application where I'm going to use the hot air on the Atari board. I'm going to preheat this part of the board. Can you try a Bluetooth microphone? Yeah, I'll try a Bluetooth microphone. That's actually what I was kind of looking for, was a Bluetooth microphone, but yeah, well, this, I'll show you what this is. I'll show you what this thing is. That's what we're using. It's an FM transmitter. I mean, it's cheap rubbish, but it does allow me to get up and walk around, and so it's better than what I'm not saying the quality is better than what I was using before, but the ergonomics of it are definitely better than what I was using before. Yes, but I suspect digital will be better, perhaps. I mean, I don't like Bluetooth, but it's probably ideal for this kind of thing. I actually bought, what did I buy? Another idea. I actually bought this thing, which is a splitter with a 4-way jack, and the plan with that was to plug it into the phone and then plug a microphone into the mic in and use an app to stream the audio from the phone to the PC to open broadcaster, but unfortunately it doesn't work because I'm assuming I bought the wrong splitter, because when I put the microphone in this thing, it doesn't shut off the internal mic on the phone, so it must be the wrong pinout. But that was another idea. But yeah, is there a Bluetooth microphone which I can use this head-mounted mic, this thing here, or something like it? If there's a Bluetooth mic along those lines, I will certainly look into getting one, because I'm still not happy with the audio on this. I'm still not happy with it. It doesn't sound lifelike somehow when I've listened to it back. It just doesn't seem it didn't seem lifelike. So I'm going to preheat this. Let's take this pylon off first. I'm going to preheat the board. The reason for this is that I don't want the hot glue to melt, I don't want the hot glue to set quickly. I want it to stay fluid. I'm keeping my distance as well, because I know these boards do not like hot air guns. That's good, it's getting there. I just want the hot glue to stay fluid for as long as possible. I'm getting there. Okay, let's try that. I'm going to put some hot glue on the board. put too much on. That was probably too much. I think I put too much on. Okay, anyway, let's just push the connector down. There we go, it's on. And I've got hot glue on the mouse, which is brilliant. Lovely. Keep the board hot. A little bit more glue along the side just to make sure that the thing stays in position. There we are. And on the other side. That's it. That's it. How about that? Right. Looks reasonably presentable. Nice and flat on the board. And on the back. Where are we? Pins that we can solder, and what I'll do, just to be doubly sure that the thing doesn't fall off, come on, focus, 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 thank you, is I'll solder a piece of wire from there to there, which will act as a sort of a strain relief, and that will be that. So what have we got left to do, which I think is going to be in the next video. We've got the VBXE to fit, and I'm going to kit this out with headers and right angle headers and stuff. This is already kitted out. What else? Rapidus. Rapidus isn't difficult to fit. I mean, it's almost done here. It's just in the adapter. It needs 3 wires. What is it? EXT cell. What else? What else? I can't remember. 3 signals anyway. That's going to sit there. I think the most time consuming part now is going to be crimping these damn wires, which I'll try and do that during a spare hour or so, because I don't want to be crimping in the mid video. I mean, I can do crimping on the video if that's what you want to see, but I'll probably pre-crimp most of the cables, because it is very, very boring crimping. So I think, how long we've been running now? Oh, nearly 2 hours. So that seems like a good time to have a natural break. I'll catch up on the chat first. Can I compile the program in Turbo Basic XL? Output via JSR DOS-any. Will this be the correct way out of spot? Oh, I've got you. I might be misremembering here, but doesn't the DOS command not compile or not work in the TBXL compiler? Because I seem to have a vague memory from about 20 years ago of doing something similar. It either wouldn't compile, or it would compile and it didn't work. Can you remember? Can you remind me about that? Because this rings a bell. This rings a bell. Does the DOS command compile at all, or does it just not compile? Because that would, yeah, sure I did something similar. So you could just do a USR little string. That would work. I'm pretty sure that's what I had to do. Check if I missed anything. Okay, I'll hang on until you checked. But yes, that does sound very familiar. Remind me to put some jeans on for the next video. Wandering around in these, what I call my comfy pants. Comfy pants. They're only comfy because they're elasticated. We'll have a little clean up. There were a few things in Turbo Basic that wouldn't compile. I'm trying to remember what they were. I've left a center punch on the desk as well. There were a few things that didn't work. I'm trying to remember what they were. Not so much immediate mode, well, what else wouldn't compile? I'm pretty sure I had to use a USR, a string, a machine code string with USR to get out of the program. And what I really wanted to be able to do with TBXL was to type the program name at the SpartaDOS prompt, and then have the program load the runtime rather than the runtime load the program, if you see what I mean. I never did figure out how to do that. I think what I did manage to do was to get the runtime to read a command line argument from SpartaDOS X, so you could type runtime and the name of the program you wanted to run, so it would be X runtime and then the name of the program you wanted to run, and I think I got that working, but I can't remember what I did about quitting the program and going to DOS. So what's this board going to look like when it's finished? I'll just do a mock-up while Atari fan has a look to see if DOS will compile. So ultimate here, no sorry, wrong way, here. What else we got in this machine? Stereo here. Has anybody but Lotharic actually built a machine like this yet? Pin one, that way. I'm going to shorten this cable. I'm totally going to shorten this cable. It's going to go It needs to be about that long. That actually doesn't look too bad. But will it work? Well, it will look a bit more busy when it's got all the all this crap on it. All these ribbon cables. It's going to look still going to look better than my 1200 XL inside. Put these back in the boxes. And don't forget U-switch. Aha. How do I get rid of this pop-up window on Twitch anyway? Twitch chat. Oh, there we go. Do you have an example? I'm trying to decide whether to go to a quiz. YouTube has deleted the URL. Can you send me a message, or you send me a message, because I'm gonna get out of here. But if you send me a message, I'll reply, and we'll talk to you about it that way, if that will help you to send URLs and stuff like that. If you want to do that, send me a message. Okay? Because I'm curious now. I really, when I've next got the emulator running, I might have a go. Okay? Yeah, that'd be great. I'll talk to you about it afterwards. I'm really debating going to a quiz. I've got minutes to decide whether or not to do it. My wife's already gone to this quiz. But I don't know, I've just got, it's 20 past 8. My mind's just a sort of, you know, just alive with circuit boards and flux and soldering iron tips, and I don't know how else I can wind down. Maybe I'll go at the quiz, and that'll be a way to exhaust my mind. Yeah. Okay, so next video, which will probably be, will it be tomorrow? Could be tomorrow. I'll have all the cables crimped, all the little wires crimped for this thing. I'll demonstrate the crimping process. The crimping arrangements will be demonstrated, but we'll speed ahead with this because it'll be pretty easy after that. Wire up the RGB jack, wire up all these other upgrades. The most of the hard work, once the crimping's done, the crimping is just crimping. If I could afford it, I would hire a crimper, just somebody who's, I mean, it wouldn't be a full-time position. It would certainly be part-time, probably 0 hours contract. But their sole purpose would be to crimp. When I need crimping done, they would be there to crimp, because I just can't stand it. I tried to buy pre-crimped wires at one point, but they were just utter shit. They were rubbish. But I digress. Anyway, so in the next stream we'll probably we might actually get to completion with this machine, because it's moving a bit quicker than I thought it did, and it's moving slowly. So okay, so thanks for watching, and I will see you next time.